On April 19, you will begin the unknown project in this course. You will be given 2 bacteria that you will need to identify. So how will you, the microbiologist, go about identifying the 2 bacteria so that the physicians can make a treatment plan? Well, first you'll need to establish pure cultures. You practice this in the Labster bacterial isolation simulation. Of course, you won't be able to actually establish pure cultures. Rather, I will assign you 2 unknowns, 1 gram positive and 1 gram negative, along with a photo of the gram stain. And from that photo, you'll be able to see shape and arrangement. But we'll focus more on those project details next week. But how will you identify the unknown bacteria? You need a plan, a path, a flowchart. You will use a dichotomous key. And the key provides a series of alternate choices that leads to the correct identification. And those choices are usually yes, no, or positive, negative. So let's do a simple dichotomous key. So if we wanted to sort out all of the faculty or of people who teach in the biology department at Calvin, how could we sort them out so that each one had a unique pathway, a unique set of yes-no questions to lead to their identification? Well, first we could start by asking, well, who teaches microbiology? Does the person teach microbiology, yes or no? The answer to yes gives us 3 people, Keen, Shen, Wirtz, and Wolsterman. So now within that group, if we want to separate them further, the next choice we could be, are they male or female? So we can sort by gender. In this case, we could ask, are they male, female? Wirtz, male. So we already have now Wirtz identified within the biology department. He teaches microbiology and he's male. But that leaves us 3 women who teach microbiology. What question can we ask that will further separate these 3 individuals? Well, we can ask, is one of them the lab manager? Well, yes, Keen is the lab manager. The other 2 are not. So now Keen, is identified. Now we still need one more test, one more question to sort Shen and Wolsterman. And the question we could ask is, do they speak Chinese? The answer for Shen would be yes, and Wolsterman no. So we have a unique pathway to each of those 4 members in the biology department. This slide just shows a simple dichotomous key used for identifying bacteria. This is just pulled off of the internet, and you can see it's just a stepwise chart consistently asking yes, no, positive, negative until each bacteria is identified. So through the semester, we've been building the information, gram stain, shape, arrangement, positive or negative results for biochemical tests, growth on various kinds of media that we will use to build the dichotomous key of alternate choices. And you'll want to build a key that's efficient, that leads to the correct identification in just a few tests. In fact, if you just randomly start doing chemical tests, you'll likely become quite confused. Now, in your case, you will perform these tests, say glucose fermentation, by asking me to do the test on your bacteria. I'll send you a photo of the results, just like we've been doing from that test. And from that photo, you can determine if the bacteria is positive or negative for that test. And then you'd move on to the next test. But where do you start in building a dichotomous key? You've been handed that broth culture. What is the first thing, the first test that you can do to separate or differentiate the bacteria into 2 groups? It's almost always the first question somebody asks about a bacteria. And the first question is gram stain. So already now we can start with this whole group of bacteria. In our course, we've got 13 possible bacteria in these unknowns, and we can begin to sort them out by asking about their gram stain. Are they positive or negative? So, but what's next? What's the next thing we ask? The next thing you can tell microscopically, and that would be shape, right? Is it cocci or bacilli or some other shape? In our case, we only have cocci and bacilli in our 13 bacteria. So you can use shape as your next step. In addition to shape, you can also use arrangement, right? Strep, staph, palisade. So that may or may not be useful. In the case of our 13 bacteria, yes, we have gram-positives, gram-negatives. Our gram-positives can be sorted into two groups based on shape, bacilli and cocci. But for the gram-negatives, there is only one shape. They are all gram-negative bacilli. So you begin your constructing your dichotomous key based on gram reaction and microscopic appearance. But after that, now what? So here's just a little hand drawing. We've got 13 bacteria at the top. We have 5 that are positive, gram-positive, and those sort into cocci and bacilli. We have 8 that are gram-negative. So what test can you do that will separate those 8 gram-negatives into 2 groups? And after you get the results of the enteric lab that you're currently doing, look at that lab, and that might help you think about tests that would be useful for beginning to sort those 8 gram-negative bacteria into separate groups. So let's say the first test you chose splits that group of 8 into 3 that were positive for that test and 5 that are negative. Well, if we focus on the 3 that were positive, now what's the next test you could do that would sort those 3 into 2 new groups? You could choose a test. Hopefully one of them would be positive and the other 2 would be negative. So in just 2 tests, you would have 1 bacteria identified. It was positive for test number 1 and positive for test number 2. Then you'd have to focus on the 2 that were negative for test number 2, determine what test you could do that would divide those 2 bacteria into 1 positive and 1 negative, and you would have 3 more bacteria identified. And so you would continue on that way, building your dichotomous key. Now please watch the Constructing a Dichotomous Key YouTube link I've provided on the Moodle page. I wasn't able to embed it directly into this recording, so stop this recording, take the 5 minutes to watch that YouTube video link, and then come back to this recording. You may find it helpful to build a chart similar to the chart or table that was used in the YouTube link. You actually have that chart in the form of the PET spreadsheet, but you might find it useful to copy and paste that data into your own simplified chart, getting rid of some of that extraneous information. A similar chart is on page 69 in your course pack, the one we use for the enteric unknowns. So that kind of a simplified chart might help you in building your dichotomous key. Here's a sample of a dichotomous key from the internet where the bacteria are listed in each step. I find this to be the most helpful in keeping track of the 13 bacteria. So in comparison to the dichotomous key I showed earlier in this presentation, where the names weren't listed until they were identified, this one I think helps you to keep track. So if you list all of the bacteria, dropping them out along the way, then you will be sure that you have identified all 13. You can use the internet to find many examples of dichotomous keys. However, you will not find one that has all of our bacteria or a key that uses the same tests. So feel free to look up examples in order to help you understand dichotomous keys, but don't try to find one that will serve as your key. So now you can begin constructing your dichotomous keys. You started, as I said, you start with gram stain, shape, and arrangement, and then begin determining the next steps in your key so that you separate all possible bacteria. This will be a stepwise test path to get to each bacteria. And I'll suggest it's probably easiest to make one key for the gram positives and another key for the gram negatives. That way it doesn't get quite so big and unwieldy. As I said, use the data from the PET spreadsheet. That's all the data you need to develop this dichotomous key. And think about, in the labs we've done, what tests might be most useful. In the test for Steph and Strep, staph and strep, we use catalase and oxidase. Perhaps those might be good tests to use on the gram-positives. And then again, look at what test we use for the enteric lab. And also, don't forget about other media we used. We've used selective and differential augers. We've used blood agar. They can also be helpful. They can also be used as a confirmatory test. For example, Staph aureus is beta hemolytic on blood agar. So maybe you have identified that one of your unknowns is Staph aureus, but you did that without using blood agar. You could go ahead and ask me to streak your Staph aureus or your unknown on blood agar, and I can do that for you, and you can confirm that yes, I did, that was either beta hemolytic or not, which can help confirm whether or not you had Staph aureus. So I'd like you to submit the start of your dichotomous keys by about April 14 or 15. So just those first initial biochemical tests after you've done the gram reaction and shape. I'd like to at least take a look at them to see if you're off to a good start. You'll want those keys completed by April 19, because on April 19 I will give you the your two unknowns, the gram stains, and at that point you can start asking me to perform biochemical tests for you. I'll send you the photographs, and then you interpret and then ask for the next test. So it really is your roadmap to identifying those unknowns. The dichotomous key will just give you the efficient pathway to do that. As far as those keys, you can use a computer program to draw them, or you can hand draw them, but just be sure that they're legible. And as always, I'm happy to meet with you if you have any questions at all.